Good day everyone! In this video, we will be talking about geometric sequences. To start with, let's have a review about sequence. Now, sequence is a set of numbers which follows a certain pattern or order. For example, we have the counting numbers, the even numbers, and the odd numbers. These three are just some of the examples of sequences, and there are still a lot of type and kinds and different patterns of sequences. So generally, if sequences have still a lot of patterns, then what pattern belongs to geometric sequence or geometric progression? To know that, let's first have an example of a geometric sequence. So we have this sequence 2, 4, 8, 16, 32, 64, 128, and so on and so forth. Now, I want you to pause the video and try to check what pattern is used in this sequence. That's right. So to get the next term, we double the term before it. So we double 2 to get 4, we double 4 to get 8, we double 8 to get 16. Or in other terms, we multiply 2 with 2 to get 4, we multiply 4 with 2 to get 8, and so on. Therefore, geometric sequence or geometric progression is a sequence that progresses through multiplication. In formal definition, geometric sequence or progression is a sequence in which each term after the first is obtained by multiplying the preceding term by a non-zero constant. So we can see a rule here. That is, the constant that we multiply, the non-zero number that we multiply is a constant. We can't have 3 here and have 4 here. So we should use the same number all throughout the sequence. Now, if in arithmetic sequence, we also have a non-zero constant that we call the common difference, what do we call it in geometric sequence? We call it the common ratio. So common ratio is the non-zero constant multiplier or factor and is denoted by R. So in this particular sequence, we can see that R is equal to 2. Now, what is the importance of the common ratio? As we can see, common ratio is defined as a constant. So if I have here 3 and I have here 4 to get the next term, then it cancels out the definition of a geometric sequence. So if it's not 2 all along, or it's not 3 for example, we have 2 here, and then we have 3 here, and then we have 4 here, then we can say that the sequence is not geometric, because one of the definition of geometric sequence is that it has a non-zero constant multiplier, which is called the common ratio. Therefore, if the common ratio tells us whether a sequence is geometric or not, if the common ratio exists, then the sequence is geometric. If the common ratio is absent, then the sequence is not geometric. Now, if in this certain sequence we just guessed that we double the previous term to get the next term, or in other terms, we multiply it by 2. What if I am given a sequence which has fractions or has decimal points? How would I get the common ratio? So, notice that to get the common ratio, we can divide the second term with the first term. And then, we will get the common ratio, which is 2. And then we have 8 divided by 4 is also equal to 2. And 16 divided by 8 is also equal to 2. And then we have the fifth term divided by the fourth term is also equal to 2. Now, why did we check it to all the given two consecutive, to all the given two consecutive terms in the sequence. Because we call it common ratio, as I have said, it should be shared with all the two consecutive terms in the sequence. So we have to check the if the ratio between 2 and 4, between 4 and 8, between 8 and 16, between 16 and 32, between 32 and 64 and 128 is the same, because it should be common for it to be a geometric sequence. In general, this is our formula to get the common ratio. We have the nth term divided by the preceding term. For example, we have 32 divided by 16. That is how we can get the common ratio. And we have to check it to all the pairs, the consecutive pairs in this sequence, for us to know if their ratio is the same. So let's try to apply the formula in getting the common ratio. So we have here our first sequence. We have 3, 15, 75, and 375. So we have 15 divided by 3 is equal to 5. And we'll check that to the rest of the terms. So we have 75 divided by 15 is also 5. Now, if the answer between 375 divided by 75 is also equal to 5, then we can say that this is geometric. So we have, therefore, this sequence is geometric. And then we have our second equation. And as said, that common ratio is denoted by r. So in this sequence, we can say that r is equal to 5. In our next example, we have negative 6 divided by 12 is equal to, this is, I'm sorry, but this is negative 1/2. Let me try to, this is a typo error. So this is 1/2. And next is that we have 3 divided by negative 6 is also negative 1/2. And then we have negative 3/2 divided by 3 is also negative 1/2. Therefore, our r is equal to negative 1/2. And in our last example, we have 15.4 divided by 7 is equal to 2.2. And checking it with the rest of the consecutive pairs or terms, we also have 2.2. Therefore, this sequence is also geometric. Now, what if I am given a sequence and I am asked to find the 11th term, or the 99th term, or the 200th term? How will I be able to get that? So this is where our formula for finding the nth term of a geometric sequence comes in. So we have a sub n, or the nth term, is equal to the first term multiplied to the common ratio raised to the power of n minus 1. So we have here the term. For example, I am asked to find the second term. So this will be a sub 2. And then I will find my first term, or the a sub 1, and then I'll get my r using the formula that I've already told you, and then substitute 2 to the 2n. So let's have our first example. So find the seventh term of the sequence 4, 8, 16, 32, and 64. So we have step 1, we should find the common ratio. This is our step 1 because, as I have told you, we should check if a certain sequence is geometric or not. We have to check if the common ratio exists. Now, if this is not geometric, we can't apply the formula for getting the nth term. So first, we have to check if this is geometric or not. So we have 8 divided by 4, 16 divided by 8, So we have 32 divided by 16 and 64 divided by 32 is equal to 2. Thus, our R is equal to 2. So this sequence is geometric because we have the common ratio. Next is that we should identify the needed values. What is this for? So the needed values will be used in substituting in our formula. So we have the first term is equal to 4, n is equal to 7 because we are finding the 7th term, and r is equal to 2. Now we substitute it to our formula. So we have a sub 7, or the 7th term, is equal to our first term, which is 4, and 2 raised to the power of 7 minus 1. And lastly, we have to solve for the missing term. Now, solving, we have 4 multiplied to 2 raised to the power of 6, and 2 to the power of 6 is equal to 64. And multiplying it to 4, we will have 256. Therefore, our 7th term of this certain sequence that is given to us is equal to 256. Now we will have our second example. So the directions are: determine whether the sequence is geometric or not. If it is, find its common ratio and the 6th term. Now remember that to check if a certain sequence is geometric or not, we should check if the common ratio exists. So on our first example, we checked it by getting all the consecutive terms and getting their quotient. And now we found out that common ratio exists, which is equal to 3. Therefore, the first sequence is geometric. And now we will solve for its 6th term. Using the formula, we will substitute the 6th term. So n is equal to 6, and our first term is 2, and our r is 3. So solving, we will have a sub 6, or the 6th term, is equal to 486. Now, in our second sequence, we have picked all the consecutive terms and solved for its quotient. Now, we have discovered that their quotient are not the same. So, common ratio does not exist. Therefore, this particular sequence is not geometric. So we will have now our third example. So given the geometric sequence 6, 12, and 24, first we have to find the next two terms, and we have to find n if a sub n is 192. Now as we can see, this is a sub 1, this is a sub 2, this is a sub 3, or the third term. Therefore, the next two terms are a sub 4 and a sub 5. So we have, using the formula for getting the nth term, we'll have a sub 4 is equal to the first term, which is 6, and the common ratio is 2. So we have divided 12 divided by 6 is equal to 2, and 24 divided by 12 is equal to 2. So solving, our a sub 4 will be, or is, 48. Then, for a sub 5, or the 5th term, we still use the same formula, and we have a sub 5 is equal to 6, which is the first term, multiplied to 2, which is a ratio raised to the power of 5 minus 1. Now solving, our a sub 5 is equal to 96. Now, our second problem is to find in what position 192 belongs. Is it on the 11th term? Is it the 7th term or the 12th term? So, substituting it to the formula, we have the nth term, which is our 192, and we have the first term 6. We have the common ratio, which is 2, and our missing number is n. So we need to isolate 2 to the power of n minus 1 to the right side because it is the term which contains the variable. So we divide it by 6, both 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 part of the equation, the left and the right, and this cancels out because this is just equal to 1, and 192 divided by 6 is 32, and what remains here is 2 raised to the power of n minus 1. Now, remember the laws of exponent. When we have a power raised to something, if the left part of the equation and the right part of the equation will have the same base, which is 2, we can just equate their exponents. That's why we have raised 2 to the power of 5, which is just equal to 32. Because our goal is for them to have the same base. Because based on the law of exponents, if they have the same base, we can just equate their exponents. So we have 5 is equal to n minus 1. And solving, we'll have n is equal to 6. Therefore, 192 is the sixth term of this sequence. So our fourth example is a word problem. So we have records at Chonghua Hospital show 210 and 50 new cases of chickenpox were reported for 3 consecutive days. Assuming that the number of new cases continues to increase geometrically, how many new cases will be reported on the 5th day? Now, do you remember the GASA method that we used in grade school to solve word problems? Now, let us use the GASA method, but let's upgrade it into GAFISA. So first is we have to write the given. Now, as you can see, we are already given a sequence here. That is 2, 10, and 50, which refers to the new cases of chickenpox that was reported on Chonghua Hospital. And our n will be the day. For example, we have 2 was on the first day, 10 was on the second day, and 50 was on the third day. Therefore, our a sub 1 is 2, our a sub 2 is 10, and our a sub 3 is 50. So next is A. What is asked? So we have here how many new cases will be reported on the 5th day. Remember that the number of cases reported is our sequence. So we are asked to find the sequence, determine the sequence, which is a sub 5, or the number of new cases of chickenpox that will be reported on the 5th day. So we have the formula, F for formula, so the general formula for getting the nth term, and I for identify the needed values. We have our a sub 1 is 2, our r, we can get r by getting the quotient of 10 and 2, and 10 and 50 and 10. So we have our r is equal to 5, then n is equal to 5 because we're finding for the 5th term. Now S for substitute and solve. So we have a sub 5, the 5th term, is equal to 2 multiplied to 5 raised to the power of 5 minus 1. So solving, our a sub 5 is equal to 1,250. And lastly, A is for the final answer. Since this is a word problem, we have to answer the question in words. So we have thus, there will be 1,250 new cases reported on the 5th day. So we're down to our last 2 examples. We have example number 5. On Monday, the first day of a flu epidemic, 3 employees of a company were absent. Throughout the week, absences mounted geometrically, peaking at 48 employees on Friday. How many employees were absent on Tuesday, Wednesday, and Thursday? So we can see here that the days of the week So we can see here that the days of the week, let me use my pen. So we can see here that the days of the week, we have here Tuesday, Wednesday, Friday, and we have Monday, is, or are, our N. So we have our N. So on A sub 1 will be Monday, A sub 2 will be Tuesday, A sub 3 will be Wednesday, A sub 4 will be Thursday, A sub 5 will be Friday, and the number of employees who were absent during those days are the terms in our sequences. So using the same method, we'll write the given. So we are given on the first day, or A sub 1, there are 3 employees who were absent. So A sub 1 is equal to 3. And on Friday, there were 48 employees who were absent. Therefore, A sub 5 is equal to 48. And then A4, what is asked? So we are asked of how many employees were absent on Tuesday, Wednesday, and Friday. So we are asked of the A sub 2, A sub 3, and A sub 4. And let's move this up because we don't have enough space for our solution. And now we have the formula and the needed values. We only have A sub 5, A sub 1, and our N, which are 2, 3, and 4, because we are asked to find 3. Next is to substitute it and solve. So notice that we still don't have our R. So using the given values and the formula, let's find our R. So we substitute A sub 5 in A sub N, we have 48. We have the first term 3, R is missing, and this is N, which is 5 because we have put the fifth term here. So solving, we get 2. So our R is equal to 2. And if some of you have forgotten how to eliminate the radical sign, I eliminate the exponent because we only need R. We have raised this to the power of 1/4, which is just equal to getting its fourth root. So imagine we have 4 raised to the power of 1/4. The 4 will cancel out, and what remains is 1. So we have R raised to the power of 1 only. That's why we got the fourth root of R4, and the same thing we did to 16. So since we have already our R, we can now find A sub 2, A sub 3, and A sub 4. So using the formula, substituting, we have A sub 2 is equal to 6, A sub 3 is equal to 12, and A sub 4 is equal to 24. And our final answer will be, therefore, there were 6 employees who were absent on Tuesday, 12 on Wednesday, and 24 on Thursday because of the epidemic. Now, our last example is this one. In a certain region, the number of highway accidents increased by 20% over a 4-year period. Now, how many highway accidents were there in 2000 if there were 250 in 1988? Now, be careful with N. So, using still the Bsed method, we have the given A sub 1 is equal to 250, which is the number of highway accidents in the year 1988. So, our N will be the year that the accidents happen, and this will be A sub 1, and after 4 years it will be 1992. So our A sub 2 will be 1992, because if we will have 1989 to be our A sub 2, and then it suddenly changes on A sub 5, which will be 4 years after, and the sequence will just 250 will just be raised to will be added by 20% of it, then we will have 250, 250, 250, 250, and 250 raised to plus 20% of it, because if we will have 1988, 1989, 1990, 1991, and 1992. Now, if we will use this sequence, we can see that after 4 years, the sequence only changes after 4 years. Therefore, if I will check, they won't have the same common ratio. They won't have the same ratio. So our common ratio won't exist. So this one can't be a geometric sequence. That's why we will use 1988 for our A sub 1, and after 4 years, that will be our A sub 2, which is 1992. And after 4 years, 1996, that will be our A sub 3. And another given is that every after 4 years, highway accidents increase by 20%. So we are asked of the A sub 4. So how did I know that 2000 is our A sub 4? So as I said, 1988 is A sub 1, then plus 4, 1992 will be A sub 2 plus 4, 1996 is our A sub 3, then plus 4, we'll get 2000, which is our A sub 4. Then we will use the same formula, and the needed values are, we only have A sub 1, which is 250, and 4 for the year 2000. And we still don't know our R. So, observe that A sub 2 and the year is equal to the year 1992. And it is said that accidents increase by 20% over a 4-year period. So, we have 250, which is on the number of accidents 4 years before, and 20% of it will be, plus 20% of it will be the number of highway accidents on the year 1992. So solving, we have here 300. So we now have two consecutive terms in the sequence, so we can solve for R. So 300 divided by 250 is equal to 120. Therefore, we can now substitute and solve. So we have here A sub 4 is equal to the first term times R raised to the power of 4 minus 1, because we are finding for the fourth term. So solving A sub 4, or the fourth term, or on year 2000, this will be the number of highway accidents. So in conclusion, we'll have, therefore, there were 432 highway accidents in the year of 2000 in that certain region. So that will be all for our topic, geometric sequence. And I hope that you learned something today. And if you want more exercises and more sample activities, just click the links below. Thank you.